My name's Chris Ballentine. I'm the Professor of Geochemistry at the University of Oxford. I've spent my career developing an isotopic tracing tool which we use to look at a whole variety of different systems, but the isotopic tracing tool is perfect for looking at the way fluids and gases move in the subsurface. They have unique isotopic compositions depending on where they come from. So if they come from the air, they have a particular isotopic composition. If they come from radioactivity in the ground, they have another isotopic composition. If they come from volcanic gas, they have another isotopic composition. When fluids from each of these different sources travel underground, they mix and they meet, and we can trace exactly where those fluids have come from. And more importantly, we can not just tell where the fluids have come from, we can tell how much of the fluid has come into the system, and we can also identify from the way the isotopes behave. We can identify the physical processes controlling the fluid migration. And those are the fundamental principles for understanding a whole range of fluid systems in the ground. And the fluid systems in the ground are and have both economic interest and environmental interest. If we want to find ore deposits, those are controlled by fluid movement. If we want to find oil and gas, they're controlled by fluid movement. And fluid movement can take a whole range of different forms and types. They can be small, local fluid movements, or they can be large-scale basin movements, or they can be fluids which have come from deep within the crustal system. And if we want to understand and explore for economic resources, we need to understand where the fluids have come from, how they're moving, and once you understand how they move in one environment, you can develop a research strategy to find them effectively. So in terms of economic benefit, these types of traces will allow us to explore for resources much more effectively. And also on the environmental side, if we want to bury, for example, carbon dioxide in the ground, we need to do it safely. And to do it safely, we again need to know the way the fluids move, how they've behaved in the past, and these traces give us exactly that information. So we can identify the safe places to bury carbon dioxide. We can identify the safe places to bury waste. So this particular set of isotopic traces that I've spent my career developing has both benefits in exploration and discovery, and also on environmental waste disposal applications. So it's a very exciting tracer set to work on and have developed.